Today we're going to be reviewing Chapter 7. You learned this at the start of February or the end of January. So it's been a couple months and your final's coming up here, so it's a good thing to review so we're not cramming everything at once. So we're going to be looking at systems of equations. So you can solve these a few ways. You can solve them by graphing. You could do guess and check, but that would take a long time. You can do something called substitution, or you can, most of you preferred elimination. So we'll start with here. By the way, you can go back and look at pages 3 through 10 in your notes. 3 through 10 for this semester have detailed notes with each process on how to do this. So if you look at the notes for elimination, which looks like it's on page 5 and 6, there's a very detailed process. I'm gonna paraphrase the process here. So the first thing we're gonna do with elimination is look for opposites, either opposite x's or opposite y's. And right here I see a set of opposite x's. So we're looking for opposites. And then once we have them, you're gonna either have them or you're gonna create them with multiplication. Then you're going to add the equations or like terms. Then you're going to solve for a variable. Because watch this is going to be sweet. Now that I have opposites, negative x plus x is 0 or nothing. And then negative 9y plus 5y is negative 4y. And we also add the constants over here. We get negative 4. So that means that y equals 1. Oops, see how it's a negative 4? We need to divide by a negative 4 to undo the negatives. So positive y equals positive 1. Which means, so since this is multiple choice here, it's probably one of these two answers, since those two don't have a y equals 1 in it. Well, which one is x, or what is x? So once you solve for that, for the first variable, you're going to use that answer to solve for the other. So now that I know what y is, I'm going to use one of these two equations. I'm going to use the bottom one. There's fewer negatives. Most of us prefer to work with positive numbers, but by all means you can use the top one. If you do your algebra correctly, it will work out. So I'm going to substitute in 1 for y. So then I get x plus 5 equals 14. So what does x have to be? Positive 9. So here is our answer. We can try that over here as well. Here we have opposite y's. See how the x's are exactly the same, but the y's are perfectly opposite. The opposite of 9y is negative 9y. So they cancel out, so I can add vertically. I get 2x plus 0y, so I'm not going to even write that down, equals negative 8 plus negative 8 is negative 16. So that means that x equals, when you divide by 2, negative 8. So I'm thinking A is the right answer. Let's just make sure that that works. So I'm plugging in 8 for x, and then really I could solve for y right now. I could subtract. Oops, let's see here, x is negative 8. Holy cow, Mr. P needs some sleep. So plug in negative 8 for x, and then you could solve for y, so add 8 to each side. I'm going to rewrite it over here. So we would add 8 to each side to undo this and isolate the y. So we're adding 8 on that side, so we get 9y equals 0. Solve for y. You get y equals 0. So that's definitely the right option. And you should notice that if you plug in negative 8 and 0 in here, that's also going to make the bottom equation true. The solution to these systems is the one point, the one coordinate pair, the one x and y pair that make both equations true. And this is the only coordinate pair that works out there in the entire coordinate plane. Here you'll notice that we have some opposites right. Actually, this one's kind of interesting. So I see a set of opposite x's. So let's go at this. Let's solve for y then. So we add vertically, we get 0. We add vertically, we get 0. So wait a minute, the x's and y's cancel out. That will happen. So what do we have on our left side? Nothing. What number is that? 0. So we have 0 on the left side, and we have -4 on the right side. Your x's and y's will sometimes both cancel out. When that happens, still add vertically, but now analyze this. If this is false, there is no solution. The answer is no solution. You can't find an answer. These two lines would never intersect if we were to graph them. Now, if you ever get something like 0 equals 0, if you get a true statement, that means that there's infinite solutions. You can look for a picture on page 7 of your notes, and you can see visually why that happens with graphing. You can go to Desmos to see what those lines look like. Cool. Sometimes you have to create some opposites. So here on number 5, the opposite of -5x is positive 5x. So you could multiply the bottom equation by -1 to get a positive 5x. So we have -5x on top. I'm rewriting the top equation. And on the bottom, once we distribute, we get 5x. And then this becomes a -5y. And this becomes a -15. So now the x's do get eliminated. Now we have -1y equals positive 5. So if we divide by -1, y equals -5. So that looks like B and C have options where y is -5. So now we go to either one of the two original typed in equations. Either this top one right here or the bottom one right there. I'm going to choose the bottom one. So -5x plus 5 times -5, I substituted in -5 for y, equals 15. So simplify first. What is 5 times -5? It's -25. -5x plus -25 equals 15. So we add 25, add 25, -5x equals 40. So then divide by -5. X equals -8. So here's my x, there's my y. So put it as a coordinate pair, x comma y. So -8 comma -5. That is the right answer. You could put those in on top real quick into that equation and see if it works out. You get positive 40 plus -20. That gets you 20. Good, that makes this top equation true. I'm real confident in that answer. Sometimes we'll have to do more than just multiplying by one number. So I think I'm going to go over here and look at number 8. So let's look at the x's first. With number 8, take a look at the x's and then pick out the larger coefficient. So the larger coefficient is this 3x. So what's the opposite of 3x? -3x. So if this became a -3x, I could create opposites. But then I have to multiply everything by whatever I multiplied this by. So I can multiply the top by 3 right now to get opposite x's. That's a correct option. I'm gonna start writing it in right now. So I can multiply the top by a 3. Instead, if you wanted to, on the bottom, the opposite of -8 is positive 8. So how do I make this become positive 8? You can multiply the bottom by 4 instead. Choose one or the other. However, you can either create opposite x's or opposite y's. So we get -3x plus 24y. I'm multiplying by a positive 3 there. So -3x, -24y. So since I'm multiplying by a positive, it's not going to change the signs of the coefficients. And then 3 times 18 is 56. So that's the top new equation. Just rewrite the bottom equation. We already have x's that are oppositized. So positive 3x, positive 2y, 12. So x's cancel out. We get -22y equals What do we get there? 68? Oh, this is supposed to be a 54. Let's use a calculator on that. 3 times 18 is 54. So let me get 66 here. Divide by negative 22. Y equals negative 3. Well, so this isn't the best multiple choice product ever. So according to these answers, it's got to be this one right here. Let's double check and let's figure out what x is. Is it actually going to be 6? You'd think so, but maybe I made a mistake somewhere. Maybe y is not negative 3. So let's see what happens here. I'm going to plug negative 3 in for y and solve for x. So I'm going to simplify first. That becomes a negative 6 right there. Now I'm going to add 6. We get 3x equals 18. So then divide by 3. X equals 6. Well, so x is 6, y is negative 3. That looks correct right there. This is a summative test. If this is something that doesn't have answers on the bottom, or if someone's betting you $100 you can't find the right answer, you're going to want to double check and plug these coordinates into the other equation. So this will become then a negative 6 right here, plus 24. Negative 6 plus 24. Or you could just type in negative 6 minus 8 times negative 3 and see what your calculator says. It will say an 18. Bada bing, bada boom. Last idea. Sometimes you have to multiply both equations by something. I'll show you what that looks like here. Like in number 11. Well, the opposite of negative 3x. So when I look at the x's, I pick the number farthest away from 0. So negative 3 is farther away from 0 than positive 2. So what's on the opposite side of 0 from negative 3? Positive 3. They're opposite. So if I could make this a positive 3, that'd be great. But I want to use whole numbers as my multipliers. So I can't really multiply 2 by a whole number to get positive 3. So instead, you could think, what's the least common multiple of 2 and 3? In other words, when you list the multiples of 2, what do you get? Here's the multiples of 2. Multiples of 3 look like this. Do we have anything on the same list yet? And try to find the smallest number that appears on both. 6 appears on both. So what I'm trying to say there is we could multiply this to get a 6, and we can multiply this by something to get a negative 6, or vice versa. So how do I create 6 x's here, or a 6x? I can multiply the top by 3. That would give me a 6x. But then if I make the top a 6x, I want the bottom to be a negative 6x. So I'd multiply the bottom by positive 2, because positive 2 times negative 3 is negative 6. So look at how this goes here. I think we'll find that we create opposite x's. So we get, when we distribute, and make sure we distribute all the way over to this 10 as well, we get 6x minus 6y equals 30. And on the bottom, we get negative 6x plus 10y equals negative 58. So, hey, I've created opposite x's. The x's get eliminated. Then I have 4y equals negative 28. So y equals negative 7. So I'm guessing this is the right answer, but let's check. Let's plug in negative 7 for one of our equations. I'm going to use the top one. So 2x minus 2 times negative 7 equals 10. 2x plus 14 equals 10. Now solve for x, folks. Back in the day, we made more mistakes just solving the equation because we weren't actually showing our work. We were just kind of guessing what that would simplify to. We get x equals negative 2. So there's my solution. So again, you're creating opposites. Sometimes you don't have to multiply either equation by anything. Sometimes you have to multiply one of them by something. Sometimes you have to multiply both equations by some value to create opposites. It's worth your while to take your time and look at what's going to be the easiest opposites to create. Have fun, good luck with elimination. I'll make a video on the other methods here shortly.